We have an expert with us today who can really talk about not only different categories of transgender women and whether they have performance advantages, but who is expert about performance differences between males and females generally, so we understand it. And so I really want to introduce Mike Joyner, who has done tremendous work in this area. He's on the faculty of the Mayo Clinic in Rochester, Minnesota. I would point out that today is his wedding anniversary. And we owe his availability tonight to the fact that his wife is was a Division I basketball player and wanted him to be with us tonight. And Dr. Joyner is in the Department of Anesthesiology and Perioperative Medicine at the Mayo Clinic. He's published widely in the area of transgender women's athletic performance, including whether it's possible to roll back male puberty with testosterone blocking drugs and estrogen. We have collected questions from you and what we think are the questions we asked kind of at the beginning of our adventure into this space. And we'll just have him answer them, one at a time, and everybody can, keep asking him questions for as long as his wife is willing to have him stay on the line with us.
So Mike, for a while.
So Mike, thank you so much for being here. And can we start by asking why we separate boys and girls in sports just before or after puberty?
Donna, if you let me, I have about 15 slides. And if we show the slides, and if people feel free to interrupt because it's a small group, the slides are straightforward. They're designed for members of the educated general public because not everybody's a scientist. And even though I'm an anesthesiologist, my research has always been related to exercise physiology since I started really as an undergraduate at the University of Arizona in the late 70s, when you were, I think, the athletic director at Texas or something like that. Yes. And so anyways, let's see if after how many years of Zoom, I can figure out how to do this. So I'm just going to talk about sex differences in human physiology for a minute. And in the rest of my life, I actually have a pretty big research program, and I'm NIH funded to look at sex differences in blood pressure regulation, and especially what happens at menopause when the incidence of hypertension starts to rise dramatically in women, but not so much in men. So testosterone in sport, high T women with DSD is differences in sexual development, the classic example being Caster Semenya. Trans women, we have controversy by people that could be described as sort of testosterone deniers about just how performance enhancing endogenous testosterone is. Who competes in the women's category? And I think Donna gave us a great intro there. Should T levels be regulated? And if so, where? Legacy physiological effects, which I think is a big issue when we think about people who've been through male puberty transitioning to female. We have the multiple political issues, and then the issues again that Donna touched on, biological sex versus gender identity. Now, I'm really going to stick with a bunch of scientific facts today, so not really going to present my views, but I'm going to try to give you what the state of the science is in terms of a couple of these things. And the goal, as I've told Nancy in the past, is to provide the facts to the extent possible to inform individuals making rules, regulations, and deciding who gets to compete as under what circumstances and what categories. So sex versus gender, there's a tremendous website on the National Institutes of Health pages, which is the premier biomedical research organization in the world. And this is really I think terrific. And I think one of the things, and again, Donna did a great job to begin with, we have to make sure that people are not confusing sex and gender. And I just took an excerpt out of this. Sex refers to biological differences between females and males, including chromosomes, sex organs, and endogenous hormonal profiles. Gender refers to socially constructed and enacted roles and behaviors which occur in a historical and cultural context and vary across societies and over time. All individuals act in many ways that fulfill their gender expectations of their society. with continuous interaction between sex and gender. Health is determined by both biology and the expression of gender.
Hey, Mike.
Yes.
Hey, Mike, question, endogenous, what does it mean?
Endogenous means something that's produced by your own body. So if you take a shot of insulin, that's exogenous. If your pancreas secretes insulin after you eat a meal, that's endogenous.
Okay, same thing with testosterone. Right.
Correct. For any quote any natural compound, or really any compound, anything secreted by your body, made by your body, is endogenous. Anything you apply from outside is exogenous. Endo meaning within, exo meaning outside.
Okay, thanks.
What can be learned from age group swimming? We got into this before the pandemic and really before the Leah Thomas news. And really, it's really a great, what we call natural experiment. First of all, women and girls have been competing for more than 100 years. Swimming was probably a little bit ahead in terms of inclusion for both boys and girls. There were limited post-high school opportunities, but really girls have been allowed to compete for a long time. In the United States, currently more girls than boys compete in the age group categories, about 2 to 1 or maybe 60-40. Those of you who've been to a pool or who are swimmers know that there's heavy co-ed training from an early age. In general, people involved in swimming are high socioeconomic status. So issues like nutrition and medical care and that sort of obvious discrimination against girls, which may occur in some other sports or in some other countries, don't occur. And again, it's an ideal experiment of nature to address some topics. And training is quite intense with a lot of interval training, starting when these kids are 7, 8, 9 years old. So it's quite remarkable. And also the conditions are highly controlled. You're in a pool. It's not hot. It's not cold. In general, it's not raining outside either. And this is what you see. This is times divergent puberty. This is age 6, 8, 10, 12, 14, 16, 18. And you can see right here about age 10 or 11, the boys start to go faster than the girls. You can see that the girls begin to plateau. And these are the top 50 times in the US at 50 meters long course. They start to plateau around 16 to 18. The boys continue to get faster. You see a similar pattern for the 100, the 200, the 400, the 800, and the 1500 meter freestyles. So again, quite consistent. And again, this happens at puberty. At the same time, here are the sex differences in puberty. This is something called NHANES, National Health and Nutrition Survey. And these are T levels in 2,000 randomly sampled US kids. And again, you can see that things are quite similar at about age 10 or 9. You see some boys starting to creep up. And then you can see that with very, very few exceptions, the boys are much higher than the girls. And the boys in the 5th percent of testosterone, so the lowest 5% of boys in testosterone at age 17 or 18 are higher than the girls in the top 5%. So there really is almost no overlap. And you can see that these values vary dramatically. Now, if you just do something very simple and plot the sex differences in swimming in terms of percentage from 0 to age or to 10%, and you look at the ages 11, 12, 13, 14, 15, 16, 17, you can see that things really take off as those sex differences in testosterone go through the roof, and in men in comparison to women. So here's what you have, or males in comparison to females. So again, at least correlation isn't causation, but certainly this would suggest that it plays a huge role in those differences.
Dr. Joyner, can I ask a stupid?
Yeah, sure, Nancy.
Stupid question is, so when you're showing the 11, 12, 13, right, and it's going up.
Yep.
Does that mean 11, 12, 13-year-olds on average are producing more testosterone?
You bet.
At those different ages?
Go right back here.
Sorry,
Nancy, you can see it starts to really separate at 11, 12, and it's pretty dramatically different by 13.
Okay.
Yeah.
Okay.
Yeah, pretty dramatically different. And the sample size of this is large enough to include people that would have what we would call early puberty, especially among the boys.
Okay.
Yeah.
Thanks.
And again, you can see these very large differences these numbers are a little bit different than some of there's a couple different scales. This is nanograms per 100 mLs, which is, forget that. And there's some other scales you see where 2.55, those sorts of things used. So a different set of units, but you can see here, out here, it's 500 versus, less than 50. So it's typically about 15 to 20x.
So 15 to 20 times greater testosterone.
Correct.
Yeah.
And I think the other thing you have to think about, Donna, is you have to think about the kind of the area under this curve. So, which is not only the amount at any given spot check, but the total level of exposure. If you think of the total level of exposure, it's not, it's dramatically different, even more so when you look at the total, kind of testosterone years underneath that curve. And again, these correlations kind of pull it out. Another thing we've looked at is if you look at breathing in female endurance athletes, women have smaller lungs, and that affects exercise hyperpnea. In other words, your ability to take big, deep breaths, and a lot of them during exercise. And so these smaller lungs make a difference and make it more likely that elite female athletes will be limited by their ability to breathe. In most people not exercising at altitude, the lung does not limit exercise. In really elite men, it does in about 20%. In really elite women, it could be 30 or 40%. So these smaller lungs make what's called the work of breathing, the energy used to activate the diaphragm, make it much higher proportionally in women than men. And when you're sending blood flow and using the oxygen to power your diaphragm muscle, that's less for your legs or your arms in the case of running or swimming. So one of the things that we did is we just recently looked at a huge number of airways. So we got scans of the lungs that were taken for other reasons, and thousands of these, and we began to look for people that had scans of their lungs for reasons other than the fact that people thought they had something wrong with their lungs, and to look at just differences in airway size when that happened, and were boys and girls different. And so we looked at this, and men have bigger airways than women. So they have, and you can see it here. Dark is males, light circles are women, and you can see the trachea, which is the big tube in your throat, and then here's the main tube to your left lung and the main tube to your right lung. So they're different, and there's really almost no overlap here. But what's really interesting is, when does this happen? And this is adjusted for height, the fact that boys are a little bit bigger, but the same thing happens again. It diverges at about age 12 or 13. And this is going to be one of these legacy effects. When we think about the legacy effects of puberty, we typically think about testosterone, things like muscle size, muscle trainability, and so forth. But there are going to be these anatomical differences where people who've been through male puberty on average are going to have much bigger airways. And it's going to allow them to get more oxygen from the air into their lungs and from the lungs to the rest of their body. Now, one of the arguments is that, all elite athletes are outliers, and we just have to live with it. And for the sake of inclusion, we shouldn't really worry about biological sex, because again, everybody's an outlier. They have big feet, big hands, they're tall, they have extra flexible this, that, or the other thing. And I think you have to look at that a little bit skeptically when you use things like the female world rankings relative to males. Now, you take somebody like Katie Ledecky, who is the ultimate outlier. She has in her best events the 800 and the 1500. I believe, Nancy, the top 20 or 30 or 40 times. Yeah, right. So I think it's nobody's even close. She's as dominant as Secretariat was in the right. Belmont Stakes. And if you look at this, she would only have the 2,442nd best swim on the male list, and just be a little bit under 500 in terms of the all-time list. So as big an outlier as she is, her outlierness can't account or can't help her catch up with above average to top men. The same is of course true for the 1500. She does a little slightly better there, but again, look at those times. So again, her incredible for lack of a better word, outlierness doesn't allow her to kind of catch the best males or even pretty good males. And there are 7,000 male swims faster than the fastest 50-meter freestyle, and the fastest freestyler would rank 4,000th, a little over 4,000 among the men. So we looked at so the arguments are biological, that performance diverges at puberty in many sports, and swimming is a good example for the reasons I enumerated. You can make a lot of arguments about things like lung size as well as skeletal muscle function, strength, and what we call trainability, the ability to respond to a training stimulus. But the other way you can do this is to look at things statistically. So if you look at, and these are long course meters, short course meters, short course yards, long course meters, short course meters, you can see all sorts of records. And these are the distances in meters or yards. And you can see that at the fastest event, the 50, the men are somewhere between 12 and about 15% faster. And that drops to about 7% when you get out to the 800, and it drifts back up a little bit in the longer event. That's perhaps because the women have only recently been allowed to swim the 1500 in the biggest meets. But you can see here is it's somewhere between about, say, 14% and about 7%. Now, if you look at the changes in Leah Thomas's times from male to female, you would anticipate if things got to complete parity, so the suppression of her testosterone and the addition of estrogen would, if that truly equalized things, you would expect her to have a 14% slower times as a female than a male. She has only about a 4.6% slower time. At the 200, only about a 2.6% as opposed to about 11%. And in the 400 or 500, only about 5.6% versus again, about 10%. Another way to look at this is her best time was 4:18 in the 500 as a male. She went 4:33. And you would anticipate that if there had been a complete kind of parity or biological transformation and all of the positive effects of testosterone had, for lack of a better word, worn off, her times would be probably closer to 4:42, 4:43, something like that. So substantially slower. We did use some other statistical techniques, and this just shows how that works. These are cis males, cis females. And in this particular case, the way we looked at the data, there's about a 10% reduction in time. And when we look at Ms. Thomas's, only about half of that reduction occurs when you look at a range of events. Again, so this is another example of the legacy of testosterone and the legacy of puberty. So the observations from our data are pretty straightforward. And that's testosterone likely explains most of the male-female performance differences in sport, and a few other things that go along with puberty, like changes in body size, airway size, that sorts of things. Even if T is suppressed, there will be legacy physiological and anatomical adaptations like airway size that might influence performance. The statistical approaches I just showed you, where you look at times as in one sex versus times in another sex, and look at the changes associated with transition and say how close to parity do you get. And these sorts of statistical approaches can be used to evaluate whether something is an outlier. And I think governing bodies may be interested in this sort of data as they decide who gets to compete in the women's category and if and how T levels should be regulated. And so what we tried to do in my group and with my colleagues is to just try to present again, the sex-based differences in human performance. What are they? What are their causes? And how durable are they? And then put that out there for the regulators to think about what's happening. And, I always think of Daniel Patrick Moynihan, the famous Democratic senator from New York, and his comment, everyone is entitled to their own opinions, but they are not entitled to their own facts. And I think the sorts of data that I've just shown you are, in fact, quite fact-based and really, while they're specific to swimming, they hold up for almost any sport that has something to do with speed, endurance, power, as well. It's a matter of degree and a matter of how big the differences are versus whether they exist. So that's what I have for you in terms of slides, and I'm happy to take questions and have whatever kind of discussion people want to have.
Hey, Mike, go back one slide. Go back one slide. Because this is your summary slide. Right?
Correct.
So,
I need to change why one I missed one spelling, but that happens sometimes.
That's okay. So, and I'm trying to translate this to what our eligibility rules have been. So when you look at the IOC rules, for instance, for many years there were 10 nanomoles, right?
Correct.
That's been done. Can you talk about in nanomoles?
Yeah.
When they say a transgender girl or woman has to get her T level down into the female range, and it used to be 10, and now it's kind of 5. Can you talk about what the female range is?
Yeah, the female range is so 5 was allowed to, was set as an upper limit, Donna, for females, biological females, because there were a few women with polycystic ovary syndrome who had somewhat elevated T, and 5 was that was where the line was drawn. But for the vast majority of women, it's 2, 2.5, 3, somewhere in there would be the upper limit of normal, with a whole lot of people below that.
And what's men? So
15, 20.
So the men start at 15 or 20 and go up.
Yeah, and they can be higher, correct. Yep.
And the women are like
2, 2.5. That would be a 2 or 2.5.
That's their ceiling.
Except for if and again, you have to be thinking about people with polycystic ovary syndrome. Right. And the other thing you have to remember, Donna, is that the rules are set so that the anti-doping folks, they want to avoid false positives. So if you look at how we call something abnormal in a clinical testing situation, typically it's maybe 2 standard deviations. So just kind of at the edge of the bell curve, in above normal, above a mean or an average. But a lot of these values that are considered, disqualifying for doping purposes are 4 or 5 standard deviations out there. And that's one of the reasons that it's been very difficult to suppress, microdosing. Because again, the goal of the regulators is to avoid, in the doping context, to avoid false positives.
Mike?
Yes.
If Donna's questions dealt with, I'd always heard, or we'd heard that the range for women was 0.06 to 1.68 nanomoles, except for a great outlier, and the guys were 7.7 to 29.4.
Yeah, that would be reasonable. So, those would be reasonable values. And again, but that's why they make them 2 or 2.5. And I believe, I don't have them in front of me, but I believe for doping control purposes, it can be up to 5. And again, those
which is high, which obviously is very high. But I wanted to know from you, the scientist, if that, I only heard of one person that was over 2 through that polycytic thing.
Yeah, right.
But I wanted to make sure that my numbers.
Yeah, your numbers would be relatively consistent with mine. And there's David Handelsman has a group of about 400 or 500 women who passed their doping control tests where they were Olympic athletes and people subject to regular testing, and he's got those distributions.
So Mike, let me continue with the eligibility relationship. Okay, so it used to be that there was just a T level eligibility, right? And now I'm hearing people say you've got to have T into the female range, and you have to look at legacy advantage.
Correct.
So let
me tell you about legacy advantages. So there's a couple ways to look at legacy advantages. So the idea of a legacy advantage, let's think about strength or muscle mass, muscle cross-sectional area, things that are key determinants of performance. So there's data from a couple of sources suggesting that when you have somebody who's been exposed to a lot of testosterone for a long period of time and you get rid of that testosterone or reduce it dramatically, that they still have some legacy effects of the testosterone. Now, skeletal muscle is hard to describe because they're not like traditional little cells like that. They're more like linked chains, and each cellular nucleus can make proteins when it's adequately stimulated by training and diet. And what happens is testosterone makes the muscle fibers fatter and bigger. It also makes more of these nuclei, and it makes it easier for those skeletal muscles to synthesize protein in response to a training load. So what happens when you take the testosterone away? It's not like all of those changes revert. And if you look, for example, in men who've had their testosterone suppressed completely to treat cancers, if they continue to train and exercise, they lose some strength, but not that much strength. And that's the main finding. People's body composition changes. Sure, they develop more body fat. They do this, they do that, and they have some female-like body composition changes. But some of the changes in muscle remain. There's also excellent animal models showing these legacy effects of prolonged testosterone exposure. And there's been some discussion about whether, and again, you have to make sure you don't conflate, people transitioning with doping. But in the doping world, some of these findings have led people to suggest that the advantages people get from doping, which is a much shorter exposure to much lower levels of testosterone, that these could last years, and that people should be, people should have, the suspension should be much longer due to these legacy effects. This was one of the controversies with that Justin Gatlin got involved with a scientist in Norway, Christian Gunderson. So explains the legacy effects. You also have body size isn't going to necessarily get smaller. People would need to think about, in contact sports, differences in body size, that sort of thing. Does that answer your question, Donna?
Is it, well, it's getting there. So we know that I'm hearing you say, I'm trying to translate in terms of my English, that the testosterone advantage in terms of muscle tissue can be recouped with training.
Yeah.
We don't know to what extent, but it doesn't disappear.
It doesn't come. Yeah.
No, here's what I'm saying. You take the level down. You get the testosterone level into the female range. You keep it in the female range.
Right.
The athlete, the transgender athlete, now gets into intensive training.
Right.
Even with testosterone in that female range, there's going to be this in terms of legacy.
Correct. In terms of their ability to respond to training and their ability to maintain some of that legacy advantage in terms of muscle strength.
Okay. And so talk also about hemoglobin. What happens?
Yeah, hemoglobin, to the extent it's been studied, hemoglobin goes down a little bit more. But remember, there's two reasons hemoglobin goes down in women. One, hemoglobin actually stimulates red cell production, and two, women have periods. So one of those things will be absent in somebody who's male to female trans.
Okay, so even though bringing testosterone down to the female range results in what to hemoglobin? It will
go down. It will go down.
It will go down to the female range?
It would go down to probably the higher upper limits of the female range. But remember, again, another reason women have lower red blood cell volumes or lower hemoglobin levels than men is because they have periods. Now, not everybody has a period. People are amenorrheic and so forth. But so one of the two mechanisms is absent. The other one, in terms of the effects of testosterone and hemoglobin, and its reduction would still be present. So there is a reduction in hemoglobin.
I don't want to dominate the question. So
no.
Go ahead, Nancy. I have a couple more, but go ahead.
Okay, just real quick. I've heard a scientist say that if somebody goes on testosterone reduction, it's in the female range, that they are, quote, within the range of biodiversity.
Yeah,
What do you think?
within the range of biodiversity, that kind of goes back to the outlier sort of things, and I think that the proof is in the pudding, in the sense that I think they may be in the range of biodiversity, but if you have somebody going from being a good club swimmer, a good college swimmer, to becoming a true elite and so forth, I think it shows that the effects of male puberty are greater than, like I pointed out with the Katie Ledecky data. The effects of male puberty are much greater than any sort of biodiversity outlier.
Huh.
So that's
Got it.
what the argument is that so all of you, I mean, almost everybody on this call is a champion of some sort or another.
Mike, this is a related question.
Yeah.
There are some women athletes who think that they're elite because they have higher testosterone levels than other women.
Right.
athletes. And is that a myth?
Well, it could certainly be something that plays a role under some circumstances.
Would they get into the male range?
No. Again, if you look down at those graphs I showed you,
Yeah.
I mean, only if you had some sort of diagnosable endocrinologic condition.
So most of the women on this call, for instance, don't have to worry about somehow I'm an outlier with T.
No, I don't think so. And I think that there are these ranges. It's not a perfect measurement of anything, but again, when you start talking about sex differences that are 10x, 20x, that's 5x at a minimum, or when the 5% of males with the lowest values have values that are higher than the highest 5% of females, that's quite dramatic. And I think the other thing that's interesting here, now this is anecdotal, is if you talk to somebody like Victor Conte, they will tell you, and I see Benita Fitzgerald there. They will tell you that the women track athletes were extremely responsive to very low dose testosterone. Which made it very difficult. Has made it very difficult in the era of microdosing to, quote, catch people, unquote.
But it's easier for if they wanted to violate doping rules.
The idea
of any woman,
tiny amounts.
Any woman who takes a very small amount of testosterone is going to have a bigger than normal.
So if you look at here's the x-axis, here's the y-axis. There's dose response curves, and when you get way out on the dose response curve, the responses get flatter. So you give more drug and you don't get as big an effect. But if you are on the steep part of the dose response curve, a small amount of a compound will get you a much bigger response. That's just a general principle of pharmacology.
Yeah.
Caster Semenya has a DSD. I have not seen her medical chart, but my understanding is that she's XY, that she has high levels of testosterone, and she has undescended testes.
So she is biologically female?
No, she's XY, making her biologically male chromosomally. She has testicles. Her testicles are undescended. And so she's got what's called a disorder or a difference in sexual development. And
Right.
male testosterone in the male range, and she's responsive to testosterone.
I wonder if I might say something.
Go ahead, Diana.
Or ask something, actually, because you said
Sure.
in the beginning, Donna, that you and Nancy and the other Donna and Mike, with your good work, I've read a lot of Dorian Coleman, whom Nancy introduced me to, brilliant. So clearly, you've been working for years now to try to get what we might call a simple definition of what is female. So if it's female sports, and we are, well, let's not look at it limiting, but we're trying to make a definition of what it takes to compete among other women.
Right.
I don't know. I love to see that anthropological chart of how long human beings have been on the earth, a very short amount of time compared to the earth, the geological earth itself, and how short it is we've been developing. Well, ostensibly, until just a nanosecond ago, we were living in a binary world in terms of gender.
Right.
That's probably not scientifically true. If anthropologists could take us back hundreds of years, there were probably all kinds of intersex individuals and transgender individuals. But as far as our societies today are concerned, it's been a nanosecond that we're not just men and women anymore. We've got all kinds of categories. So there's the issue of human rights. And here we are, all of us
Right.
on this call. Donna's described us as being open and loving. And when it comes to all those teammates of Leah's at University of Pennsylvania, Nancy, your interview with them and article is brilliant about it. All of us say, please live your life, do everything you want to do, pray and eat and marry and have children and vote, do everything you want to do. But what is the definition of a woman athlete? And is it so simple, Mike, as saying if an individual has gone through puberty as a male, as a biological male, it doesn't matter afterwards, after puberty, how much estrogen one takes, how much you change your hormonal profile, all of those legacy aspects are still going to make you a superior athlete than had you been born female. So should we make that the simple cutoff? If you went through puberty as a male, then you cannot compete with women athletes.
So I would say that you know there are this is where the sort of split the baby kind of question becomes, because I agree with you. Everybody wants to find some way for everybody to participate. And I think what you could say and what we've tried to do is simply say, you know, what are the sex differences? What are the causes of the sex differences? What happens when people transition? And how can we determine whether they retain some sort of advantage? And it's of note that we don't have, you know, this issue is brought about because of this very high profile case and a few others like it. With the cyclist in the UK currently, we don't see it happening the other direction when females transition to males, or excuse me, female, male. I'm trying to think of the correct phraseology down it. But anyways, when we go female to male, we don't see it because all the testosterone in the world doesn't necessarily catch them up because they did not have it during growth and development. So the argument is a little bit flipped there. So I think all I can do as a scientist is say, here's what the data is. And then it's up to a variety of people to try to balance it out. And I think Donna Lopiano mentioned earlier, that the Olympic Committee said we can't have one size fits all, said that we have to look at the science, we have to do this, what happens with puberty and so forth. So I think that that's where we're stuck. And as we try to work through this, one of the questions I like to ask people is before medical intervention, what kind of cancers can you get? Can you get testosterone? Can you get testicular cancer? Can you get ovarian cancer? Can you get, can you get uterine cancer? Can you get prostate cancer? Those sorts of questions are another way to think about, who's male or female, what medical conditions can you get? And what are the names of those sorts of diagnoses before medical intervention? So, but Diana, I think you hit the nail right on the head here, is that certainly somebody could argue that anybody who's been through male puberty should not be allowed to compete in a female category. That would be one thing. Whether that's going to be where people end up drawing these lines, and whether one federation is going to do it one way, a different federation is going to do it another way. Who knows? Who knows how that baby's going to be split? I don't. Nancy, do you?
So I can answer that a little bit. Okay, so the national data sets that start, I don't know when it's middle school, high school, but we have big national data sets, and they ask whether you participate in sport, either outside of school or inside of school, but they don't ask the question whether you're transgender. So generally the answer is no, we don't know, but the Williams Institute out in California has made some estimates of percentage of transgender in the general population, and they were looking at about 0.7%. And if you say it's 0.7% also play sports, if you make that, it's a fairly small number. And then the question becomes, what is the impact of that number?
And always in things that get politicized, the sorts of data sets you're talking about are always going to be overwhelmed by these examples that people want to have. And well, that's what's happened in the last 6 months. We have an example of somebody who's, gotten very good and is disrupting sort of the status quo one way or the other. If this wasn't, and this is very high profile because it's about somebody competing at the championship level. To the extent people are identifying earlier in life, I think the big issue that's going to happen in a few years is going to be people that never went through puberty, and how that's how that people address that. Nancy.
Yeah. I just want to say, like, they're different from a policy perspective, not from Mike's scientific perspective, but there's two ways that you can go about not having enough information. One is let in until we get the information, or alternatively, we want to enforce the boundaries of the category, and then as soon as we have enough information to let people in, right? You can kind of go two different ways with that, but if we have the women's category for a particular purpose, and we don't have the research showing that that's fair, then, right? So, but again, that's a policy perspective, Lynn, that goes to, you have a small percentage. We have lots and lots of examples. I think some people on this call have examples that they've competed with.
Yeah, and if we could, I think, bringing up a policy question, which we have to end up with, but I want to stay focused while we have Mike for a limited period of time. Let's keep to some science questions for just a little bit. Tracy?
So looking at the numbers, and you just mentioned the high profile case with Leah. Looking at the numbers, it defies, and knowing that there was no transparency as to her testing and the like. When we've had transgender kids compete in my high school events, I saw monthly what they were in the female range and how all those numbers played out. Is it your opinion that she really wasn't on gender affirming hormones in a
No, I think from my understanding, the NCAA rules are she would have had to have been.
Wait, the NCAA rule says you have to be on gender affirming hormones for a year. You could take your first shot on January 1 and your second shot on December 31, and you have met that standard. There's no level in the rule that shows monitoring as it goes along. So if we look at the statistics that you have pointed out as to her performance, either she is an amazing outlier due to her size or whatever, or she has not gone through the same level of intensity of mitigation that a June Eastwood or a number of other athletes.
I would err on the assumption that she has undergone the mitigation, and attribute her relative improvement as a female as opposed to a male. I would attribute that to the legacy effects of testosterone and body composition in conjunction with continued training.
So that shows up a bigger potential problem going down the road as to creating guide rails to how we find people, allow them to compete, which is clearly where hopefully we can find. She did not, I don't even think she qualified at that point to compete in the trials, which were, a year plus earlier.
No, that's old school.
No.
That's a different
That's
era.
old.
That's pre-Title IX actually, and one of but they've continued to do well.
Yeah,
Yeah,
but
they
they
didn't
continue to get better
peak.
and faster. But they
Yeah,
didn't
they
peak.
didn't peak.
The other thing, if you look at men prior to in the era of amateurism, the number of people that competed men who competed much after age 22 or 23 was quite low. People would hang on for a year or two after college, and then they were done by and large. And the same was true in track and field, because people had to go get jobs. So the number of people competing into their middle to late 20s, there were a few people who did, but it was very unusual.
My
And right
first
now-
Olympics, the average, the great majority of the women's team were high school kids in 72. There were like six that were collegians, all went to HBCUs, which are the only schools that had scholarships. And there was like 4 post-collegians. The guys pretty much stopped prior to when we could earn money in 80, as Mike just said, after you got out of college. But the average age of the US Olympic track and field team, which I was the team leader in 16, was 29.6.
Yeah, swimming's
That's
gone
okay.
up as well.
Okay.
Yeah, swimming's
Roger.
swimming's also way up. Yeah.
Okay.
Yeah, I was 22 back in 1984, I went all my best times, and that's now 22 is young, right? There are some that are young, but the average age, I don't know the exact average age, but it's older than 22.
Mike, another question in terms of where these eligibility rules seem to be going. And so now they're saying we've got to break everything down by event and sport because, and it seemed, I'm sorry, did somebody say something? I'm sorry. By event and by sport, and that your charts seem to say, in terms of looking at how distance, you've shown the differences in time, that the more explosive the event, the more explosive the sport, the greater the legacy advantage.
So swimming is a little
Or-
different because of the nature of the water and the way water resistance and speed work together. If you look in running, it's about 11% at every distance. So this decline, because as you go faster through the water, the physics are straightforward. It gets much more strength is going to play a much bigger role. Yeah, go ahead.
No. So I want you to come up with some kind of a statement that includes the relationship between explosive versus the hemoglobin distance,
right.
Whatever, and how, just for example, you suspect that might turn out in terms of event sport.
Right. And so there's always going to be a sex difference. The curvilinear nature of that difference, where it's a little bit less as you go longer in swimming, is due primarily to the way the water works and the way pulling yourself through the water resistance, the fact that there's, especially as you're going a little bit slower, the fact that women have slightly different body compositions and a little bit more body fat, that's less of a penalty because they float. And again, that's much less of an issue when you're going for 20 or 40 seconds. There's some parallels with cycling. When you go from 25 to 30 miles an hour, you have to double your power. You have to double your power output strictly because of the wind resistance. Because it goes up in a curvilinear way. So the physics of this are kind of worked out, but it can be difficult to explain because most people are not thinking about exponential rises in wind or water resistance. But those would be the sorts of things. You see some similar things in rowing, but the distances in rowing, they have a standard different distance for everybody, 2,000 meters.
So, okay, so
I must say, and Nancy, you're probably the best one to answer this, because if you take a case like Caitlyn Jenner, okay? Caitlyn Jenner is 72 now, agreed, not a world-class athlete anymore, but a good athlete and a very competitive golfer. But Caitlyn Jenner says she would never enter a women's golf tournament at this stage. She's competitive. She likes to compete. Women because she knows it's not fair. The other women her size, I mean, her age more or less cannot drive the ball as far. She lives those legacy traits. So why I'm curious about the other transgender athletes like Leah. Does Leah not say outwardly, I still feel, as much as the estrogens changed me, I've got something of my male self as an athlete? Am I naive to think that she doesn't know that? Nancy, what do you think?
Yeah, no, she doesn't say that. She says, I'm a girl, I'm a woman.
All the way.
And she says, yeah, I identify as a woman, and that equals that I am a woman for all purposes. There's no carve out for anything for,
Yeah.
Okay, sticking with Mike again. So Mike, am I correct in saying, I'm hearing you say that whatever the eligibility rules are in the future, they cannot be T only?
I think they have to be a combination of T would be certainly one, but I think you have to look at, did people go through puberty? And I think, depending on the sport, you can use some of these statistical approaches that I outlined there. And I think you have to think about non-T effects as well. The Y chromosome does other things. It makes you taller and some other things as well. And I think that it's going to be very, very difficult to both try to get it's going to be very difficult to for a lot of reasons to get a uniform standard. I think some of the regulators and some of the sports federations would like to have a uniform standard. If X, then Y. But I think you see it with the differences in sexual development in track and field, where they've really focused on, I think, Tracy, the 400, the 800, and the mile, correct?
Well, the answer is yes, because there weren't, quote, enough data points when when Castor took it to to CAS.
Correct.
And despite World Athletics, the IAAF at the time, saying, no, it needs to apply to everything. It's testosterone and drugs affect the shot put as much as they do the 100. They limited because they had only these women competing at that point in the 4 to the mile. It turned out that World Athletics was right. There was not just one. There became Castor, then Francine, then Margaret. They went 1, 2, 3 in the women's 800 in Rio. And then in Tokyo, 2 teenage quarter milers from Namibia dropped down to the 200 and 100, made the finals at both in the 200, got a silver medal there.
Terrible starts too.
Oh, the best last 70 meters I've ever seen in a 200-meter race.
Yeah.
Looked like Usain Bolt.
And are we talking about intersex? Or are we talking about?
We're talking intersex. We're talking intersex.
Yeah, these
Castor-like things.
And then a girl also went up to the
3,000.
10,000. She made was 5th in the 10, got DQ'd for a lane violation in the 5, and then set a world record at 2 miles later in the summer, and is dominating. We hope that that'll get revisited now that there are more data points outside of that 400 to 50.
And as you guys know, you're thinking about people like Stella Walsh and the Press sisters, the DSD issue has been around for a long time.
But in most Western society, all of that is caught in the prenatal and addressed prenatally, but not in Africa, which, makes my sport a bit more, people accuse us of being racist when we bring it up.
And that's one of the reasons that's one of the reasons I said swimming is a nice natural experiment, because for lack of a better word, you've controlled for some of these issues you've talked about, in the sense that it's primarily happening in relatively developed countries among people that have relatively high socioeconomic status and have access to the sorts of medical care you're talking about.
But Lynn St. James, just in the last minute, I think that this little back and forth between Tracy and Mike has been indicative of, yes, we could take a big, sort of a chart and just how many transgender, and let's even throw in now intersex athletes
Yep.
who we all probably are thinking should have a separate category, should compete not against cisgender women. And you're saying, but Lynn, but at this point in our point of this progress, there are very few, not really, 3, the gold, silver, and bronze at the 800 meters at the Olympics, none of whom are categorically women. So we're already in a space of, as many people have said besides me, it won't be that long before we will not know the next Venus Williams, Serena Williams, Nancy Hogshead Makar, because there are the Leah Thompsons of the world who, those women at University of Pennsylvania, one day, let's just say one day one of them receives her PhD. They won't be able to say, I was 4-time NCAA champion, something that it's not just for inclusion that we compete. We compete to be the best we can be against the people
Right.
we compete with. It's already happening. It needs to be addressed now.
Well, and I think that this is, I mean, these are the things that people are trying to work their way through, because people want to be in as inclusive as possible. People want to be fair. I think everybody on this call recognizes, the for lack of a better word, the benefits of Title IX for everybody. And I think you have a variety of other issues in here besides, I was talking to one of my friends who runs a residency program, and if somebody has All-American on their application to medical school or wherever, that's the kind of thing that can get somebody noticed, gets them pulled out of the gets them an interview, for example. Is it going to be definitive? No. Does it give people a second look? And I think that's one of the things that people have to think about.
Yeah.
But it's worse than that. I was going.
I won't get into the second part of the question, because these are political decisions, right?
I know.
And no, these are political decisions, and they've got a lot of constituencies. And I'm just saying that's a fact. What I think there is a pretty good consensus among what I would describe as mainstream physiologists, biochemists, and endocrinologists. I think that there is tremendous push for inclusion at all, for inclusion among the trans community. I think, on the other hand, there are people thinking about the fairness issue and struggling, like many people on this call are. And I think the other thing to think about is and again, it's impossible to divorce it from these issues. And I'm just trying to give people the facts to the extent that they exist. So I think there will be more quote facts unquote in the coming months, years, and so forth. And I think it should be able to develop a pretty clear biological consensus about what's going on. And then the question is how much does that influence regulators and rule makers of various sorts? I think the other thing is, for those of you who want to learn more about this at really kind of a lay level, there's a woman named Carol Hooven at Harvard, who's a biologist and teaches a class on sex differences, and it's just a terrific book where she gets into this, I mean, up and down the animal kingdom, talks about the trans issues and so forth. And I would really encourage you to, buy 5 copies and get one for yourself and distribute them widely, because I think it's the best primer on the very much larger issues that people are talking about.
That's right.
It's
Yeah.
Carol Hooven, Carol with a Carole, Hooven, Hooven, and it's T, the story of testosterone, the hormone that dominates and divides us. It's a terrific book.
Okay.
And kind of written at the Scientific American, National Geographic level, so you don't have to have a have to have a PhD in biophysics to understand it.
Before I let you go, Mike,
Yeah.
we let you go. Go ahead, Jema. Did you have a question? Sorry.
Yeah, I had a quick question. I'm constantly hearing that we need more science in this area for justification not to change the rules or
Right.
vice versa. Ideally, what other science would you want?
Oh, I think the science is pretty clear, actually. And I think this is never going to be something where you're going to do a classic randomized controlled trial. where you're going to do the perfect sort of study that we would use in clinical medicine to test a treatment. And so I think we have to rely, just like we have for things like other things where we've relied on epidemiology, to look at a combination of case studies, look at what the biological mechanisms tell us in animal models and in human studies as well, in terms of some of these hormonal effects, and then look at the statistical data like that I presented. So I don't think you're ever going to get, perfect, do a perfect experiment where you get a large number of people that or some get this, some get that, and you can really say, hey, it's this amount. And I'll give you an example of what we did is the new running shoes that Nike made and other people are now making are thought to, in the lab, give you a 4%, 4% improvement in performance. We showed that in the real world, it's probably closer to 1%, which is still substantial. But again, we did not do a perfect randomized controlled trial and have people run one day with the shoes, one day without the shoes. In a race, we were able to extract this data from databases. So I think that these sort of natural experiments and the sort of observational data that we have in conjunction with what we know about the biology of testosterone and the sex differences, harking back to that NIH definition I showed very early, I think we can make very reasonable I think we have enough science, enough information to inform the rule makers. What they do with that is a separate issue.
But Mike, one of the things we talk science, but in this day of fake news, it now seems that we have fake science, and you have groups trotting out their scientists saying, "Oh no,
correct." So I think
do you want to shoot these people? What do you want to do?
No, I think, I think again, I try to, as calmly as I can, look at the data, multiple angles of the data from, like we were just talking to Jema, in terms of a whole kind of chain of data, and look at the whole epistemological landscape. Epistemology is, how do we know what we know? And see if what sort of puzzle we can put together. And so I just try to keep my eyes on those balls and provide this information to people who are interested in it, so that they can make the judgments that they have to make in their policy making roles.
But how does real science win over people just saying, "Oh,
Well, historically, real science does well over time.
Okay.
Yeah.
One more question, Mike. Do you have anything to tell us in terms of collision sports?
I think there's less data on that because it's much easier to get this sort of statistical stuff I'm talking about, and the physiological determinants, in something where it's swimming, running, that sort of thing, lifting, where it's what do they call it? Centimeters, grams, seconds, or kilogram seconds. So I think obviously people are concerned about, in sports where size can make a difference, there could be these sorts of collision issues, safety issues. To me, that's sort of common sense thinking. If somebody was 20 or 30% larger and fast, very fast and powerful, it could be an interesting thing, for example, in rugby. There's something called Tanner stages, and they have ways to do this. The endocrinologists and pediatricians have ways to categorize, for lack of a better word, sexual development that associated with puberty and in various stages, I think 1 through 5. And so many young people are now being, in the male to female space, are now being getting puberty blockers when they're at stage 1 or 2, which is quite early. So again, that sort of information is available, and the people who take care of especially the pediatric transgender people, have protocols and ways to categorize these sorts of things.
Yeah, I would just say, just from an anecdotal standpoint, any of us who have both male and female children I won't say could answer that question, but all I remember is my son was 12 years old, and we'd been at the beach and we taken some photos, as you do. And I went off to the World Championships right afterwards, and I was hanging out with some of my old Tennessee friends who were managers on the team. And I was showing them the pictures, and they go, "Oh my God, look at Isaiah's six-pack." Like, what are you talking about, six-pack? And I looked at the picture, And not only him, but his best friend Ziane, who went to the beach with us. They probably had 8-packs. I'm sorry. And yes, they were basketball players and track athletes and, football players and everything else. So they are definitely, very well, very fit. But at 12 years old, 12 and a half, they were full on puberty. You know what I mean? At that age. And definitely when I saw my daughter at 12 years old, she looked nothing like that. I can just say.
Right. No, and I think that's why I think you'll really enjoy that book from Carol Hooven, because it does a great job. And there's some incredible stories from the animal kingdom too, where people have done interventional studies in animals that have cyclical changes in their testosterone, and how the behavior changes and so on and so forth. It's most interesting. And I think again, some of the
send us all of the reading material, even the website, the NIH website. That
I'll get those. I'll get those to
Okay.
Nancy. It'll be, or in Casey, it'll be the NIH website, which is just really one page, and the Carol Hooven book.
Thank you.
Is that what you need? Yeah.
Yes. Thank you.
So yeah, I think you guys, it's been great visiting with people. I'm happy to provide input at any time. Many of you who, I'm fans of many of you, or certainly familiar with your tremendous accomplishments. And I think the other thing, I was telling Nancy this, and I told Donna this, is somebody who really was administratively in leadership, right there with Title IX. I was on the first co-ed track team at the University of Arizona. So, and I think one of the things that people fail to realize is how much Title IX did for people like me. To some kid in the middle 70s to actually learn how to take women seriously was very helpful. Very helpful, and it's helped me, deal with my female colleagues. And I don't think it's weird that there are women surgeons, stuff like that.
Right.
Michael, thank you so much.
Yeah, thanks everybody. It's nice to visit. I have a 12-year-old boy who's going through some of the same things it sounds like your son did right now, so we'll see how many times he flexes in the mirror.
Oh yeah, for real.
When he gets
It
home.
goes right to their heads.
Yeah, it sure does.
Yeah.
All right, I'll send you that stuff right now.
Thanks, Mike.
Nancy,
Thank you,
and I'll
Mike,
see you
so
guys later.
much.
Take care,
Thank
everybody.
you.
Yep, bye-bye.
Okay.